Welcome to your first lesson in Kickstart to Algebra. Today we're going to be learning about equations. Some of the things you may see today you have already done in your previous classes, and some stuff you may be learning for the first time. Feel free to print off the notes and follow along with me, or use a piece of paper and write these problems down. Or just sit here, listen to the video, and see what you can do out of these things. A homework assignment will be to follow every lesson. Okay, so the first thing we're going to do is just a couple definitions of an equation. So the first one is an equation is a mathematical statement that shows two expressions are equal. A solution is any value that makes an equation true when substituted for the variable. The inverse operations that we will be using to solve equations: addition is the inverse operation of subtraction. Because addition and subtraction will combat each other. So if we're adding something, it's from a subtraction, or if we're subtracting something, it's because it was being added originally. And then we also have multiplication. And the inverse operation of that is division. So same thing with addition, subtraction. If something is multiplied, we divide it, and if something is divided, we multiply it. There are a couple ways to solve equations, but the most efficient method is called the algebraic method or the symbolic method. That's what we'll be using today. Your instructions are to solve the equation, show every step, and then we will check our answer to make sure we are doing it correctly. So the first problem I have, 10 equals r plus 2. Okay, the variable that we are solving for in this equation is r, and we can see here that 2 is attached to r with an addition. The inverse operation of addition is subtraction. So I'm going to subtract 2 from both sides of the equation. This plus 2 and minus 2, because they were inverse operations, they cancel each other out. And I get here 10 minus 2 equals 8. And I'm left with r on this side of the equation. The last thing I'm going to do is I'm going to go ahead and flip this back around, so I have my variable r equals the value of 8. Starting off pretty simple, we can check our work by plugging it back in. So I have 10 equals, and I'm plugging in 8 for r. And I do know that 8 plus 2 equals 10. So this checks off, and r equals 8 is my solution. All right, number 2. Negative 12 equals negative 12x. For this next one, we are solving for a variable x, and negative 12 is attached to x with multiplication, since it's just sitting right next to it. So the way to get rid of multiplication, the inverse operation would be division. I'm going to divide this side by negative 12 and divide this side by negative 12. Well, negative 12 divided by negative 12 is positive 1. These will cancel, which just leaves me as x. And I can say x equals 1. Plug it back in to solve and see if it checks. Negative 12 times 1 equals negative 12. So this is my solution. Number 3, 4p plus 7 minus 5p equals 11. All right, so we have a couple more steps to do in this one. Before I can get P by itself, I notice that P is in two places. I only need that P in one place, and since they are both on the same side of the equal sign, we call this combining like terms. So if I have a positive 4P and a negative 5P, combining them on the same side, I don't have to do any inverse operations because I'm not moving anything over the equal sign. So combining 4P and negative 5P, I get negative 1P, or you can write that as negative P. Plus 7 equals 11. Everything else comes down the way it was with my equal sign in the correct spots. Next, getting P by itself, I only have it in one spot. So the first thing I'm going to do is subtract 7 from both sides, because we do addition subtraction first. That's why I listed that as our first inverse operation. I'm just going to write this as negative P equals, this will cancel, and I have 11 minus 7 equals 4. Next, I don't want negative P, I want positive P on its own. So this was that negative 1 attached with multiplication. So I'm going to divide both sides by negative 1. And I get that P equals 4 divided by negative 1, which is negative 4. When you check this one and put it back into the original, I would plug in negative 4 in both of those spots in the original problem. So 4 times negative 4 is negative 16. Negative 5 times negative 4 is positive 20. So I have negative 16 plus 7 plus 20, which gives me positive 11. So I know this one has checked off. Okay, moving down to number 4. We have 8 minus 3/4 A equals negative 4. Just like we did before, we are going to first, we have here this 8 minus 3/4 attached to this A with multiplication. So we're going to get rid of this 8 first. Bringing 8 to the other side, this is held together with subtraction. However, 8 is positive. So in order to move 8 to the other side of the equation, you have to subtract 8 on both sides. This will cancel off my 8s, and I'm left with negative 3/4 A equals negative 12. Now, this next step here might seem a little bit tricky. Negative 3/4 is attached to A with multiplication. And it seems to be that we've been getting rid of multiplication with our inverse operations with division. However, it is not mathematically appropriate to divide by fractions. So in order to get rid of this negative 3/4, we can actually multiply by the reciprocal. The reciprocal is the inverse of the number negative 3/4. So I'm going to take this and I'm going to flip the fraction as negative 4/3. So if I actually check this multiplication, negative 4 times negative 3 on top gives me a positive 12, and 3 times 4 gives me a positive 12, and 12 divided by 12 will cancel off to 1. So multiplying this negative 3/4 by negative 4/3, which we call the reciprocal, this will get rid of that fraction without dividing by fractions, because it's not mathematically appropriate. So I'm going to multiply this side to be fair, also negative 4/3, doing the same thing to both sides of the equation. Once again, if you also can see this cross simplifying, the 4's cancel and the 3's cancel and the negatives cancel. I'm left with A equals, and either you can plug this into your calculator put this 12, negative 12 over 1 and multiply across to simplify. Or you could actually cross simplify here, the same way I cross simplified the 4s and the 3s. I'm going to cross simplify the 12 and the 3. Well, I know 12 and 3 are both divisible by 3. 12 divided by 3 would give me 4. 3 divided by 3 would give me 1. Cross simplifying has simplified this problem, and I no longer need a calculator because I have negative 4 times negative 4, and 1 times 1 on bottom will just leave 1. So this actually ends up giving me a positive 16. You can plug positive 16 back into the original problem, and it will check off to give you negative 4 on this side of the equation. All right, number 5. Our problem is 6 times the quantity of 6n minus 3 plus 6n equals negative 186. Now for this problem, we have 6 times a quantity. Before we can do anything with both of these n's on the same side of the equation, I need to simplify what this 6 times the quantity is. We call this distribution. I'm going to distribute the 6 to the 6n, and I have 6 times 6n, which is 36n, and 6 times negative 3, which is negative 18. The rest of the problem I'm going to write down as plus 6n equals negative 186. My next step looks very similar to what we did in number 3. I have 2 n's on this side of the equation now, and I'm going to combine my like terms. My positive 36 and positive 6 will give me a positive 42n. And then I'm going to write the rest of the problem down as minus 18 equals negative 186. Now I have 2 steps to get n by itself. Always do addition, subtraction first, and then multiplication or division. So what I'm going to do with this one is I'm going to add 18 to both sides, since addition is the inverse of subtraction. And then I have 42 times n, so I'm going to divide both sides by 42. And I get n equals negative 4. You may need a calculator for that one. Plugging negative 4 back into the original equation, everywhere I see this n will check off to negative 186. So this is my solution. All right, the next one looks very similar to number 5. Let's go ahead and write that one down. 1 plus 5 times the quantity of 8x plus 8 equals 281. If you would like to try this problem out on your own, you can pause the video. If you have some trouble, you can play the video and watch me work it out. But once you have finished pausing the video, working the problem out, please push play again to check your work. Okay, if you tried this one out on your own, follow along. If you didn't, please write this down as we go through. The first thing I did is I distributed that 5 the same way I distributed the 6 to this previous problem. So my next line reads 1, because I've not changed anything about the 1, but then I have positive 5 times 8x and positive 5 times 8. So I end up with 1 plus 40x plus 40 equals 281. Now, different from this problem, but similar concepts, I have like terms over here, but this time, instead of being like terms on the variables, I have like terms on the constants. So I had a 1 and a 40 on the same side of the equation, and I can add these two together to get 41. Next, I have 2 more steps to get x by itself. Since 41 is attached with addition, the first thing I did was subtract 41 from both sides. Once I got 40x equals 240, 40 was multiplied to x, so I divided both sides by 40. 240 divided by 40 gave me x equals 6. After I finished, I went ahead and plugged 6 back into the original problem, and it checked off equaling 281. 6 is the answer. I hope you got it right. Moving on down to number 7. This one's a little bit different, so we are going to work it together. We have 8 minus a all divided by 12 equals -6. Now usually we do addition subtraction first and then we get rid of multiplication or division. However, this entire problem is divided by 12. So my first step for solving, I'm going to multiply both sides of the equation by 12. This 12 will cancel with this 12 on the bottom. And I have 8 minus a equals -72. Next, I have this 8 attached right here, minus a. However, 8 is positive. So in order to move it to the other side of the equation, we have to subtract 8 from both sides. And I have negative a equals -80. My last step, this negative a, is the same as -1 if you want to place in a coefficient of 1 there. So I'm going to divide both sides by -1, and this will cancel to get positive a equals +80. Plugging that back into the original, this will equal out to -6. So this is our solution. All right, number 8. Also slightly different, so we are going to work this one together. I have n plus 4 equals -5n plus 10. The difference in this problem is that we have n's, 2 of them in different places. However, they're not on the same side of the equation. So like we did in number 5 and also number 3, where we could just combine like terms, I actually have to move one of the n's to the other side of the equation. It doesn't matter which one you move to which side, as long as you perform the correct inverse operation. My favorite thing to do when I find variables on both sides of the equation, I like to take the smaller one to the other side. So I am going to take this -5, since -5 is less than 1, and I'm going to add it to the other side of the equation. The reason I have to do the inverse on this is because it was not like this problem. These were on the same side of the equal sign, and these are on opposite sides of the equal sign. But I am going to add it to the n because those are my like terms. Simplifying to the next line, I have 1n plus 5n to get 6n, plus 4 stays there like it was. This is what canceled off, and I'm left with 10 on this side of the equation. Now this looks like our typical two-step equation, and I'm going to first get rid of the added 4. So I'm going to subtract 4 from both sides. And my last step, since 6 is multiplied to n, I'm going to divide both sides by 6. Plugging 1 back into the original equation, both here and here, 1 plus 4 is 5, -5 times 1 is 5, plus 10 gives me +5. So 5 equals 5, and 1 is my solution. All right, the last problem on the front page is 8 times the quantity of -5 plus x equals -38 plus 7x. If you'd like to try this problem out on your own, go ahead and pause the video. If not, I will be doing step-by-step instructions on how to solve it. Okay, the first thing that I did is I distributed this 8 times the quantity of -5 plus x, which gave me -40 plus 8x. Next, I noticed I had variables on both sides of my equation. So since my 7 was smaller, that's the one that I did the inverse operation to. However, it is not incorrect if you took the 8 to the other side. I subtracted 7x from both sides and simplified to get 40 plus x equals -38, or 1x. My next step is I had 2 steps here, this -40, so I added 40 to both sides, and I got x equals +2. Hopefully, even if you did a step slightly different than me, you also ended up getting x equals +2. When you plug 2 back into both sides of the equation where you see x, you should have gotten these equations to equal each other. All right, our next step to do is our word problems on the back side. So please flip your page over. For each of these problems, we must set up an algebraic equation. Solve the equation by showing each of the steps. Okay, so our first problem here says 7 less than a number is 20. Find the number. Now we're going to start off pretty simple. However, we do have to set up an algebraic equation. So just finding the answer is not part of the problem. Part of the problem is actually being able to set up an algebraic equation. The first thing we're going to do is we are going to set our unknown. The question, or the actual statement it says here, says find the number. So I'm actually going to take this part right here and set this as my unknown variable as n. Then I'm going to read what the problem is telling me about this equation. 7 less than a number, and this is the same number we are solving for, is 20. 7 less than something, so 7 less than a number, means that number, n, that we have set to be the number, but I want it 7 less than it, so -7. The word is means equals, and it is 20. Once we have set up our algebraic equation, we can solve our equation. Since this is -7 to my n, the inverse of that is to add 7 to both sides. Then I get n equals 27. And I have successfully set up the algebraic equation, solved it, and showed every step. You can also do the same thing we did above by plugging it back in to check your work. My final thing to do is to write a quick statement answering the question. The question said, find the number. So my answer is, the number is 27. And this is my solution. Okay, similar to that, number 2 says 4 more than 3 times a number is 80. Find the number. If you would like to work this problem out on your own, go ahead and push pause. If not, I am going to work this problem out step by step. Okay, if you wanted to work it on your own, I hope you push pause, but I'm going to go ahead and work it now if you wanted to work it with me. The same thing applies here. You can use any letter you want, but when I'm just finding a number, I like to use n or even x sometimes. So I'm going to set n to be my number again. And now I have 4 more than, just like our 7 less than, but this one is actually going to be adding. So 4 more than 3 times a number. So 3 times a number would be 3n, but I wanted 4 more than that. So I'm going to add 4 to the outside. Is or equals 80. All right, so then we just have to solve the problem by first subtracting 4 on both sides. And then dividing both sides by 3. 76 is not divisible by 3 evenly, so I'm going to leave it as an improper fraction. You are also welcome to leave that as a proper fraction, but I typically use improper fractions in algebra. So my sentence at the end will be, the number is 76 thirds. All right, number 3. We are into some more context problems now. Jan has 4 more dollars than Matthew. Altogether, Jan and Matthew have $19. How much money does Matthew have? Well, the question is asking about how much money Matthew has. So I'm going to set M to be Matthew's, and I'm going to put a little dollar sign to say that is Matthew's money. Now I have 2 different things going on here though, and I also have this person named Jan. I'm going to go ahead and set a J for Jan and see what we can do to set up an equation so I only have one unknown. So the first part of the problem tells us that Jan has 4 more dollars than Matthew. So I'm going to put Jan right here. Jan has, which is the same thing as is, here's my equal sign, 4 more dollars than, so it's going to go on the other side, 4 more dollars than Matthew, and I set Matthew to be M. So M plus 4. This literally says Jan has 4 more dollars than Matthew. All together, meaning Jan and Matthew. So Jan and Matthew all together means to add. They have $19. Now I have 2 different equations here. However, I only want one equation with one unknown. So I'm going to take this little expression here that I said about Jan, and I'm going to replace it in that equation with Jan. So I'm going to say M plus 4, because this represented Jan, plus M equals 19. So this basically means Jan's money, which is 4 more dollars than Matthew, and Matthew's money equals $19, but I only have one variable now to deal with. So in order to solve this problem, I have 1M and 1M on the same side of the equation, so all I have to do is combine. M plus M equals 2M plus 4 equals 19. Next, I'm going to solve for M by subtracting 4 on both sides. And then dividing by 2. Now, some of our things may or may not make sense as decimals, but this represented Matthew's money, and money can be written as a decimal form. So my final answer, I'm going to say, answering the question, how much money does Matthew have? Matthew has $7.50. That's what this 7.5 means, and that's what I got for BM. All right, there we have solved the problem. Number 4, bags of maple granola cost $3 more than bags of apple granola. The owner of a restaurant ordered 5 bags of maple granola and 4 bags of apple granola. The total cost of the order was $60. What is the price for a bag of apple granola? Well, the first thing I'm going to do is I'm going to go straight to that question, asking about apple granola, and I'm going to set that to be my first unknown. So I'm going to put A as apple granola. Similar to the last problem though, I have 2 types of granola. Earlier mentioned was maple. So I'm going to set this up as maple granola as M. So I'm going to go back to the original part of the problem. It says bags of maple granola. Bags of maple granola cost $3 more than bags of apple granola. So a similar process, I'm going to say maple costs $3 more than apple. So apple plus 3. The next thing I'm going to do is I'm going to read what it is all together. They ordered 5 bags of maple, 4 bags of apple for a total cost of $60. So 5 bags of maple and or plus 4 bags of apple equaled the total cost of $60. But once again, I don't want these 2 unknowns. So I'm going to go to where I started writing my apple in terms of maple, my maple in terms of apple, and replace that in my equation. So I have 5 bags of maple, which is A plus 3, and I need to make sure every bag of maple is $3 more than every bag of apple. So this 5 goes to every bag purchased. 5 times the quantity of A plus 3. Plus 4A equals 60. Now we have solved problems like this with this distribution here. We have to distribute the 5. 5A plus 15 plus 4A equals 60. I've got variables on the same side of the equation, so all I have to do is combine them. 5A and 4A is 9A. Solving for A, I'm going to subtract 15 on both sides. I'm running out of room, so I'm going to pull it up here. 9A equals 45. And divide both sides by 9. And I get that A equals 5. So I have found the cost of a bag of apple granola because A represented the apple granola. My final answer I'm going to write as a sentence by saying a bag of apple granola costs $5 each. Okay. Moving on to the next problem. If 4 is subtracted from twice a number, the result is 10 less than the number. Find the number. Well, similar to 1 and 2, I'm going to state n as my number. And I'm going to write exactly how it's telling me the problem is written. 4 is subtracted from twice a number. So twice that number minus 4, because 4 is being subtracted from it. The result is, here's my equal sign. 10 less than the number. So 10 less than the number I'm looking for. Notice in this problem, I've got variables on both sides. The way we solve this one, we cannot just combine 1 and 2n because they are on opposite sides of the equal sign. So I look for the smaller one. Comparing 2 and 1, 1 is smaller. So I'm going to subtract 1n from both sides, and I get n minus 4 equals negative 10. My next step to get n by itself is adding 4 to both sides. And I get n equals negative 6. You can plug any of these problems back into the original just like we did on the front page. My final answer is the number is negative 6. All right, last problem. A container A has 200 liters of water and is being filled at a rate of 6 liters per minute. Container B has 500 liters of water and is being drained at 6 liters per minute. How many minutes, M, it has told us this time, our variable, will it take for the two containers to have the same amount of water? So it has told us what letter to use for our unknown. How many minutes? We are using M. And we want our containers to have the same amount of water. Basically, I want container A equal to container B. And this is how we'll solve the problem. Container A starts with 200 liters of water. And it's being filled at a rate of 6 liters per minute. Well, I know M stands for minutes, and we are being filled, so I'm going to add 6 liters per minute. Equals, and I have container B. Started off with 5 liters of water, but this one is being drained. So I have, 500. 500 liters of water being drained, meaning I'm subtracting out of that 500 6 liters per minute. 6 liters per minute. And now we can solve our problem. We have variables on both sides, 6m and negative 6m. Negative 6 is smaller than positive 6. So I'm going to add 6m to both sides of the equation. And I have 200 plus 12m equals 500. Next, I need to get m by itself, so I'm going to subtract 200. And next, I have to divide by 12. And I get that m equals 25, which stood for our minutes. So my final answer with my sentence, they will have the same amount in 25 minutes. There's my answer. If you would like some extra practice with this, please print off the homework that goes with it. Once you are finished with the homework, you can check your answers on there. If you have any questions about the notes or the homework, please feel free to email me on Canvas. You can email me to my email, or you can message me on the Remind app. The Remind app is the quickest way that I can respond. All right, hope you enjoyed your first lesson.